Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahirrahmanirrahim. Inshallah, we'll continue, I think, few slides in Spark Streaming, and then we'll start, inshallah, a new session about Storm. We didn't talk about the lineage graph in this stream and what we do with that in Spark Streaming. If we start with that program, then Spark Streaming will create the lineage graph for it. So we'll see here we have in the code we have Twitter stream, then we have map, and both are transformations, and then for each which is an output operation. So we'll see that the lineage graph, the links here are the dependencies. So for each stream, which is an output operation, depends on the mapping, which depends on getting the input stream from Twitter. Why is that important? Let's look at another example. Here is two input streams. Then we get the union of them. Then we apply map on the union. Then we save it, and we also do two for each operations. So what would be the lineage graph here? So can we do it together? So what would be the lineage graph here? Any idea? So we start with the root. What is the root? The root is, Sorry? There's T1 and T2, right? So we have two roots here, two input sources. So we have T1. So let's use this. T1 and T2. Then what depends on them? Yeah, so we have the union of T1 and T2. So we have T. Right? Then there is a map here. Let's call it M. Sorry, the dependency should be the other way. Okay. Okay, then saving, right? It's an output operation like action, yes, but we also represent it in the lineage graph. So let's say saving. What else? Yes, but we just represent it because it will indicate a job that we need to run. Okay. What else? There's another map. So this map depends on what? So we did that map, right? So there is a map here, and this is for each. Oh, sorry. So I think we did something wrong here. So T depends on T1 and T2, right? And then there is a map on T, so that's M. Okay. So is there any mistake here?
The T is after the map.
Yes. So this is no, T is not after M.
That's okay.
So M is this map. Okay. Map comes after the union, but now this saving is on. Sorry.
Okay, union should be an RTD, then map should be another RTD.
Yes.
Okay, where is the union?
Then this is not T. Sorry. Yeah. Okay. So I got your point now. So this is okay. So let's do it again. So let's call this U, the union. Right? And then there is a map Then, Reem, can you be with us, please?
T the output after.
Yeah, this is T, right? Yeah, that's T. The T is the map, right? Okay. Then, so this is the map, not to forget, because that seems that confusing. Okay. Then, then you save T. Okay, so that's like an output operation. Okay, so let's do it like that. Save. Then the map on T. So let's call it M this time. Then for each on the map. For each here. So that's for each. Are we done? Yeah, there's another one here. So filter depends on T. Filter. And then there is another for each here. Okay, so that's the lineage graph for this code. Okay, and you will see that we have three output operations. So each one will be a job that will run on Spark. Now so that's I guess what we did here. Yeah. So so let me erase this then. Now this graph, you remember that the Spark streaming is working on top of what? Of Spark core. Okay, so this lineage graph will be converted into Spark lineage graph. Okay, so which is very similar with actions here. So each of these operations will be actually actions in Spark, and that will generate the jobs. Okay. So every so the idea here is that every lineage graph in Spark streaming has a mapped lineage graph in Spark, okay, which is used for what? Why do we need this lineage graph in Spark? For fault tolerance, right? If something goes wrong, if something failed, then I can go back to the lineage graph and regenerate it. Okay. Right. Let's talk about persistence in Spark streaming. First, generally, if a D stream is persistent to at some level, then all RDDs generated by this stream will be set to that storage level. Okay, whatever that storage level is, memory and memory plus disk, whatever. Okay, whatever level that this D stream is set to will be translated into all RDDs that are in this stream will have this storage level. Okay, so that's another mapping. So we saw the mapping in lineage graphs. This is also in persistence. Okay, but that's applied, of course, because the D stream is a stream of RDDs. Then, whenever we say this will persist at some level, then all the RDDs in that stream will be persisted at the same level. Okay. When should we persist these streams? Of course, if we reuse it. If it's used multiple times with multiple transformations, then we should persist it. A special case here that is not in Spark, because we have stateful operations. Whenever we have these streams from the window-based operations or state-based operations, if you remember last time we talked about this will be automatically persist in memory because we need them to do this windowing operations. So this by default will be persistent. And the input streams, and that's another special case, that the input streams, the very starting inputs, okay, that we get, will be replicated by default twice, so that we don't. This is for tolerance for them. If that source failed, then we have a copy of the data that we can use to do fault tolerance for any failed nodes in the cluster. Okay, so two special cases here. These streams from window-based operations or state-based operations will be automatically persisted in memory, and also the input streams, the default persistence level is set to replicate the data in 2 nodes for fault tolerance. Okay. Right. There is another mechanism also in Spark streaming, which is checkpointing. Okay. So what is checkpointing? Basically, this is also very similar to the meaning of checkpointing in general. That means that we will save the RDDs to HDFS to prevent the graph from going too large. Okay, so at some point, or actually periodically, the RDDs will be saved to disk. Okay, so that if we need to go back to the lineage graph, we don't need to go back very far in the past. We just go back up to the checkpoint that we have. Okay, so that will make the recovery very fast. So if I code the checkpoint on, for example, this green RDD, then it's like adding saving operation. Of course, this is done automatically by Spark streaming every period of time. Okay, so that will be a copy of the RDD that is output at that point. Okay, so we don't need to regenerate it from scratch or from the beginning. Of course, this is in parallel to the actual tree. This dependency will not. It's like we are breaking the dependency now. Okay, so there was a dependency here. If we didn't do the checkpointing, right? So if I need to get this, I have to go back to the root of the tree, right? But now we broke this dependency and we save it to disk every period, so we don't have to go back. Okay, is that clear? This concept? Right. Why is that necessary? We already, I think, hinted about that. Some operations can have infinite lineages. Think about any stateful operation. Stateful operation means that we depend on the new input and the current state, right? Which means that we actually depend on all the previous inputs since we began. Okay, so that's very, very long lineage graph. Actually infinite if we run this infinite time, unbounded. Okay, so we have to break this very long back in history by checkpointing, and that will lead to, of course, high recovery time. Okay, I mean, not this kind of large lineages will lead to high recovery time, but if we do checkpointing, that would be much faster. The recovery time, which will be much faster because I don't have to go back in time that long. Okay. So periodic RDD checkpointing solves this problem. Now how frequent we should do this checkpointing. That's, of course, trade-off. If we do it very frequently, that will slow down the computations, right? Because we are writing to disk, right? And if we do it infrequently, then the recovery from failures will take more time. So we'll have to think about this trade-off. Okay? Of course, ideally, we might say, okay, we need it to be very frequent, but that would slow down the computations, of course. The default checkpoints in Spark streaming is about 10 seconds. So every 10 seconds, the RDDs are checkpointed. If, of course, we set checkpoint to a specific RDD, that's not by default. Okay, but what is done automatically is the saving. And once we set, once we call checkpoint for the stream, for the D stream, then the checkpoints will be saved automatically. You don't need to really explicitly save them, but we have to set it. Any questions so far? Okay, I think the last part is fault tolerance. Of course, we started to talk about it already, but let's focus on it, I think, for the last 3 or 4 slides. We said that the input data will be replicated twice, right? So that's good for fault tolerance. If we lost any part of the input, then we can get it. So that's the first level of fault tolerance that we have. Okay, so that we have the data is replicated. Now, replicated in memory, of course, okay, so that we can get it easily. Now, if there is any data that is lost to due to worker failure, then we can get it from the replicated input data. Now, if some part, so just to be clear, there are 2 things here. We are talking about replication of the input data. So if we lost any part of it, we can get it because it's replicated. Now, if we lost some part of the data after being processed at any worker, then we can also get it from or run the process on other nodes than the nodes that failed and get what we lost. Okay, and that's of course using the lineage graph and using the checkpointing. Yes. Yeah. Okay. Very good. Of course, that you will be limited by your memory. Remember when we talked about Spark, we said that there is an eviction policy, right? The least recently used. So eventually, some part will be evicted. Okay. If the memory is limited, and memory is limited anyway, and that streaming by default is running infinitely, unbounded. So you will have to do it at some point. It's a good question. Any other questions? You have a question, Aman? There's a question on your face. Okay. Right. One nice thing also is that we can do parallel recovery. If some part of the data, let's say that this node failed, okay, and that node has 3 RDDs, okay, then we don't need to generate, we don't need to get this data on one node, on another node. We can get these 3 pieces on 3 different nodes, okay, in parallel, because the data is distributed, right? So we can, we don't have to do it on one node or do it sequentially. We can do it in parallel. Of course, assuming that this is part of the same RDD, these are partitions, or maybe different RDDs. Okay. Yes, of course, if there is dependency, you cannot do that. Okay. But remember that all RDDs are distributed. So these can be even different partitions of the same RDD or partitions from different RDDs, assuming that there is, of course, no, it depends on the type of the dependence, yes, whether it's narrow or wide, it depends. Right? But this is possible. If it's allowed, then we can do it in parallel, and that will make the recovery faster. Okay, all in one, if you look at these two pieces of code, one is using Spark Core to read from Twitter log files, and the other, very similar, is getting the tweets from Twitter stream. Very similar code. Okay? And that's, of course, very convenient. Yes.
So we are using now Twitter stream, which is transformation, I think, built in the
Spark streaming, yes,
framework.
yes.
Suppose I have, for example, control system, and I'm getting data from the control
Yeah, you
system.
can write,
I can use the same transformation?
you have to write your own if it's not there, if the current library doesn't provide that specific source, then you will have, but there is an API that you can use to get that. Yeah. And we mentioned last time that it supports multiple input sources. Okay. So at least you have to check first what are the sources that are supported currently, and if it's not there, then you have to extend them. And the vision of Spark is always having one stack to rule all of what we need to do, or most of what we need to do. Okay, so you can use the interactive shell to write commands. You can write standalone programs, and you can standalone programs for Spark or for Spark streaming. You can also do both. I think we had an example last time when we use both Spark streaming and Spark core together in the same program. I think when we did it with union with a static RDD or something like that, if I remember correctly last time. So it is possible that you can use both together in the same program, okay? With very similar, at least how it looks. How they look, the code, they look very similar. Of course, you know that underneath they are different and the processing is completely different. But for the programmers, knowing one will make it very easy to know the other, to learn the other. Okay. Questions? I think that was the last slide. Any questions about Spark streaming? No questions? Okay.